Hello everyone. Today we are going to start talking about absolute value and what absolute value means, and eventually where we're going to go is to talk about absolute value functions and how to solve an absolute value equation. But before we start, let's just review the real number system. Okay, so the real numbers are all numbers that exist in our world and that are defined. Okay, these are divided into two different categories. One category is the rational numbers, and the symbol that we use for rational numbers is the symbol Q. And a rational number is defined as a number that can be written in the form A over B, where A and B are both integers, and we'll define integers in a second, but B cannot be 0, because if we divide by 0, then we get something that's undefined. Okay, so typically when people think about rational numbers, they think about fractions, which is a good way to think of them, but you have to always also remember that both the numerator and the denominator can't be irrational. Okay, so we'll get more into that in a second. Examples, basically any terminating decimal, meaning that the decimal ends at some spot. Any repeating decimals, repeating, non-terminating decimals. Okay, so something like 0.22222 repeating, that would be a rational number. Some examples, and these can all, although they aren't necessarily written as a fraction, they can be written as a fraction. Something like -3/4, 0.17. You could write that as 17 over 100, for example. 0.82 repeating. Okay, this symbol on top means that the number those two digits 82 keep repeating, so it's 0.828282, etc. The square root of 16, because that simplifies to 4. Something like 3. That's rational because it can be written as 3 over 1. Okay, these are all rational numbers. Okay, now the rational numbers can be broken up into some smaller categories. And there's 3 smaller categories. The first one, this is the largest of the 3 smaller categories, is called the integers. Okay, and there's 2 symbols that are commonly used for the integers. One of them is I, and the other one is Z. And integers are basically positive and negative whole numbers. So they can be positive, they can be negative, but they cannot have a decimal or a fractional part. So like -3, -2, -1, 0, 1, 2, 3. And this keeps going on forever and ever. You could have 2.0, that's okay, but you can't have 2.1. Okay? So the integers, the rational numbers, a subset of the rational numbers are the integers, meaning there's a smaller set of numbers within the rational numbers called the integers. Within the integers are a smaller set called the whole numbers. And whole numbers, we use the letter W to abbreviate those, are basically integers that start at 0, 0, 1, 2, 3, 4, etc. Okay, and then within the wholes are, I'm running out of room here, but I'll squeeze it in, the natural numbers. And the natural numbers, we use the letter N. And the natural numbers are essentially the whole numbers starting at 1. So all the whole numbers except for 0. Okay, so this is kind of a summary of the real numbers, the rational numbers, I should say. We haven't talked about the irrational numbers yet. The irrational numbers are basically anything that's not rational. The symbol that we use for them is a Q with a little hat on it, and that little hat essentially means not. So not rational. And these are any numbers that cannot be written in the form A over B, where A and B are integers, elements of the integers, and B is not 0. Okay, so in decimal form, what do these look like? They are non-terminating, meaning they never end, and non-repeating. They don't repeat decimals. Okay, so a lot of radicals are irrational. Okay, so for example, the square root of 2 is irrational. Any square root of a non-perfect square is going to be irrational. The cube root of 16 is irrational because 16 is not a perfect cube. Those are all irrational. Pi is also a very famous irrational number. These are all irrational. Also something like this, where you have something like 0.1211211121112. Well, there's a pattern to it. It's a non-terminating decimal where there's a pattern, but it's not a repeating pattern. That is also an irrational number. Okay? All right, so that's a little summary of the number system, the real number system. By the way, there are also such things as imaginary numbers. You will learn about them when you get to maybe 3rd or 4th year university if you continue to pursue mathematics. But we're not going to go into those right now. They're essentially the square roots of negative numbers. Okay? All right, so absolute value. What is the absolute value? Okay, well, the symbol that we use for absolute value are these 2 lines. Okay, this is our symbol. And the way that we would say this out loud is the absolute value of X. And essentially what it means is how far is X from 0? Okay, now because we're talking about far, this is a distance, it must be positive. Okay, so absolute values are always positive because they are a distance from 0. Okay, now if we're looking at the absolute value of 7, the absolute value of -7. If we were to draw that on a number line, here is 0, here is -7. The distance between these two numbers is 7. So the absolute value of -7 is 7. The absolute value of 3, if we were to draw that on a number line, here's 0. Here's 3. This is a distance of 3 from 0. Okay, so the absolute value of 3 is 3. And essentially, when you're taking the absolute value of a number, you're taking the magnitude of the number and ignoring the sign. Okay, so the absolute value of a negative number will be positive. The absolute value of a positive number will also be positive. Okay. All right, let's try a couple of examples. Here's the first one. Write the real numbers in order from least to greatest. Okay, so we've got all of these numbers here. We want to write them in order from least to greatest. Well, what you might want to do here, because some of these are absolute values, some of them are not, is just write the equivalence of the absolute values without the absolute value symbol. So evaluate the absolute values first. Okay, so what is the absolute value of 3.5? It is, and maybe I'll do this in a different color. The absolute value of 3.5 is just 3.5 because 3.5 is a distance of 3.5 from 0. Okay, then we have -2. That's just -2. So I'm just going to rewrite that as -2. The absolute value of -5.75 is positive 5.75, right? -5.75 is a distance of 5.75 from 0. Then we just have 1.05. There's no absolute value symbol there. Then we have -13, or the absolute value rather of -13/4, and that is just positive 13/4. We have the absolute value of -0.5, and that is positive 0.5. Then we have -1.25, and then we have the absolute value of -3 1/3 rather, which is just 3 1/3. Okay, so when we are putting these in order from least to greatest, what you want to do is not put in the red numbers, but put in the original values. We're going to use these red numbers that I just wrote in to help us order from least to greatest. But we want to make sure to actually use the forms of the number that were given to us in a question when we're doing the ordering. Okay, so there's only two negative values once we evaluated the absolute values, -2 and -1.5. So those ones obviously will be the smallest, and -2 is the smallest one, so that will go first. And then -1.25. Okay. It looks like the next smallest after that is is this guy, 0.5. Now the form that we were given of that number was the absolute value of -0.5. So that's the form that we want to use. And what I like to do actually is as I use them, I just kind of cross or check them off. So I've used that, I've used that, I've used that. Okay. And then after 0.5, the next biggest number is 1.05, and the form that we were given was just 1.05. Okay, now the other thing that I should do probably is 13/4. Everything's in a decimal except for that one. Well, I mean, 3 1/3 is a mixed number, so that's a little easier to think about. 13/4 is, what is that? 3 1/4. So I'll maybe write this one as 3 1/4. Okay, so the next two that we're looking at sort of in the threes, 3 1/4, 3 1/3, 3 1/2. So 3 1/4 is going to be the smallest of those three. And the form that we were given for that is the absolute value of -13/4. And then 3 1/3 comes next, and the absolute value that we were, the form of the number that we were given for that is -3 1/3. So I'll check that off. And then the next one is 3.5, which the version was the absolute value of 3.5. Check that off. And oh, I forgot to check off 1.05, but I did use it. And then the last one, which is the greatest value, is the absolute value of -5.75. Okay, so I have ordered these from least to greatest. And once again, just make sure that when you are giving your final answer and you have ordered them, that the form of the number that you answer in is the form that you were given in the original question. Okay, all right, evaluate each of the following. So absolute value of -4 plus the absolute value of 3. So we have to evaluate each of these absolute values first and then add them together. So this is going to be 4 plus 3, which is 7. Okay. For the next one, the absolute value of -4 plus 3, the absolute value of all of it. Well, this, you almost want to treat this like brackets. We have to do this first. Okay, so -4 plus 3 is -1. So this is the same as the absolute value of -1, which is 1. Okay. All right, next, the absolute value of -5 minus the absolute value of -2. That is the same as 5 minus 2, which is 3. Here we have to do this piece first, right? So what is -7 minus 10? It's -17. So we're looking at the absolute value of -17. Okay, and that is 17. Okay, and then here again, this piece first. And we have some BEDMAS stuff going on here. So we have to think about doing the exponents first, right? So this is going to be 12 times -3 all squared is 9, plus 5 squared is 25. And then what is that? 12 times 9 is 108, plus 25. And 108 plus 25 is the absolute value of 133, which is just 133. Okay, so there we have those. Okay, so here's our last question. Wesley volunteers at a local hospital because he's interested in a career in healthcare. One day he takes the elevator from the 1st floor up to the 6th floor to see his supervising nurse. His list of tasks for that day sent him down to the 2nd floor to work in the gift shop, up to the 4th floor to visit with patients, and down to the 1st floor to greet visitors and patients. What is the total change in floors for Wesley for that day? Okay, so when you're thinking about distances traveled, right, we can think about the difference in positions and the absolute value of those differences in positions. So let's say you start at 2 and you end at 6. The difference in positions is -4. But if you take the absolute value of that, now you've actually gone a distance of 4. So we can work out the total distance that he's traveled, or total floors, using the difference of floors that he's gone in each step, but taking the absolute value of those differences, because then we eliminate any of the negative values, any of the negative differences. Okay, so total change would be, well, where does he start? He starts at 1 and then he goes to 6. So that's the first difference. Okay, then he goes from 1, let's see, 1st to 6th. Okay, then he goes to the 2nd floor. So he starts at the 6th and he goes down to the 2nd. That's the second difference. Okay, then he goes up to the 4th. So he goes from the 2nd to the 4th. That's the third difference. And then he goes down to the 1st. So he starts at the 4th and goes down to the 1st. Okay, so these are like the 4 different rides that he takes, essentially. And if we look at the difference in floors in each stage, but we take the absolute value of those differences, then we eliminate all of the negative differences and we can just think about what is the total distance traveled. Okay, so let's see what that is. This is going to be the absolute value of -5 plus the absolute value of 4 plus the absolute value of -2 plus the absolute value of 3. Okay, and that all together is 5 plus 4 plus 2 plus 3. And that works out to be, let's see, 9 plus 2 is 11 plus 3 is 14. Whoops. 14 floors. Okay, so I am going to leave it there for today. And we will continue tomorrow talking about absolute value functions.